Okay, once again, our discussion is on the antiderivatives of some transcendental functions. And the first one will be the antiderivatives of exponential and logarithmic functions. Okay? Now, before we are going to start, let us recall the following theorems that you learned sa derivatives. Okay, so these are some of the differentiation rules about exponential and logarithmic functions. So first, we have here the derivative of e raised to x with respect to x is equal to itself, right? So we have e raised to x. We also have here the derivative of a raised to x with respect to x. A here is a number greater than 0 but not equal to 1. So that defined yung exponential function. Okay? That is equal to a raised to x ln a. Okay? So we have the second one. And the third one, we have the derivative of ln x with respect to x is equal to 1 over x. So these are some of the differentiation rules na na-discuss natin sa derivatives na lesson. Okay? Now, as what I've said sa last meeting, antiderivative is just the reverse of derivative. So therefore, from these rules, we can actually have rules for the integration or for the antiderivatives of exponential and logarithmic functions. So if follow lang natin ito, okay, so we have these theorems on the antiderivatives of exponential and logarithmic functions. So we have for the first one, since the derivative of e raised to x is still itself, e raised to x, therefore the integral of e raised to x with respect to x is equal to e raised to x plus c, because we are taking the indefinite integral. So therefore, there is always this plus c. Do not forget this one. Okay? Then for the second one, we have here the integral of a raised to x dx is equal to a raised to x all over ln a plus c. Now, sir, parang iba yung result kanina. Di ba from the previous slide, we have the derivative of, ano nga yun? A raised to x, a raised to x with respect to x is equal to a raised to x ln a, right? So that is the derivative kanina. Now, if you are going to take the integral of a raised to x ln a dx, the answer should be a raised to x plus c, right? But take note, ln a here is now a constant or number, a numerical coefficient of e raised to x, because our variable of integration is only x. And ln a here, wala siyang x. So therefore, I can put ln a outside, okay, the integral sign. So we have ln a integral of a raised to x dx na lang, right? And that is equal to a raised to x plus c. Now, from that, para mawala yung ln a, we will divide both sides of the equation by ln a. So what will happen? We have a raised to x dx. Then we have a raised to x ln a plus c over ln a. Now, c over ln a, c is a constant, ln a is a constant, and we don't know that one. Therefore, we can represent that one as one constant. So that's why we have the integral of a raised to x dx is equal to a raised to x ln a plus a certain constant. Suppose we have capital letter C, ganon. So that's why this is now the um, formula in integrating a raised to x. I hope that is clear. Okay? So baka nalito kayo kasi iba yung derivative, pero ganun yung nangyari. Okay? Sinimplify niya lang. Now, next. For the third one, we have the integral of x to the negative 1, and that with respect to x to the negative 1 is 1 over x. That is the third rule kanina. Okay? 'Di ba the derivative of ln x is equal to 1 over x. So the integral of 1 over x with respect to x is equal now to ln absolute value of x plus c. Bakit nilagyan natin ng absolute value ng x? So that para mas ano tawag doon, malawak yung domain niya. Because if we will just put ln x, okay, nalilimit yung value ni x. Okay, it should be greater than 0 lang. Because ln of a negative number is not defined. Right? So, dito, nilawakan niya yung domain ng x. So, from that, we will put absolute value. Okay, so even though x is negative, there will always be that value of ln absolute value of x. Then we have plus c. I hope this is clear. Do you have any questions, clarifications? Okay, so take a screenshot of this theorem because we will apply these theorem later sa ating mga examples. Okay, do you have any questions, clarifications? If none, kindly press 2. Okay. Kindly press 2. Ayun. Okay, so once again, take a screenshot ha kasi gagamitin natin siya mamaya. So let us now practice. Okay, let us practice. So what we're going to do is to evaluate the following integrals. So the first one, we have the integral of 2 e raised to x with respect to x. So let's have number 1. Yan. So number 1 dito. Okay, so we have the integral of 2 e raised to x dx. I think na may nag-feedback. Mag-feedback yung phone ko. Oh, ayun. Wait, hinaan siguro natin. Okay. Yan. Is it better? Better na ba? Wala na nag-feedback. Okay. So, yon. So, we have the integral of 2 e raised to x dx. Now, from our theorem, okay, last meeting, we have, if you have a constant times a function, we can actually take the numerical coefficient outside na. Ilalagay natin sa labas yung numerical coefficient, right? So, therefore, we will now have 2 integral of e raised to x dx, right? And from that, what is the derivative? Integral of e raised to x again. Kindly write it down in the comment section. What is the integral of e raised to x? Still e raised to x, right? So therefore, integrating e raised to x dx, the answer will still be e raised to x. So our final answer will become 2 e raised to x. Then we will put plus c. And this is now our final answer. I hope that is clear. Do you have any questions, clarifications for this one, guys? Okay lang ba? Are we all good? Okay, none siguro, no? Madali lang naman siya. Let's have number 2. Then you will do the rest mamaya. Okay? So we have number 2, the integral of 3 e raised to x plus 4 raised to x. Then we have with respect to x. Ayan. Now, from that, from our previous theorem, we can actually distribute the integral sign here, right? Okay, so distributing the integral sign, and if you can factor out the numerical coefficient, then pwede nyo lang gawin. Okay? So from that, pwede kong ilabas si 3, right? Then we have the integral of a raised to x. Then we have plus the integral of 4 raised to x dx. Now, here, baka yung iba ilalabas si 4. 4 here is not a numerical coefficient. Okay, so this is the base of the exponential function. Okay, 4 raised to x yan. Huwag niyong ilagay si 4 sa labas. Okay? So from that, we will now have, again, wala palang dx dito. Dapat may dx yan. Ayan. What is the derivative, integral of e raised to x? So it is still e raised to x. So we have 3 e raised to x plus, what is the integral of 4 raised to x? What theorem are we gonna use? Is it the first, the second, or the third one? Among the three theorems na na-discuss natin kanina, what theorem are we gonna use for this one? The integral of 4 raised to x, second theorem, right? Or theorem B. Now from that, from theorem B, we have the integral of a raised to x is equal to dx is equal to a raised to x ln a plus c. Our a here is 4, so therefore we will now have 4 raised to x over ln 4. Then we have plus c. And we can have this as our final answer. I hope that is clear. Any questions, clarifications? If there is none, kindly press 2. Ayan. Now you try number 3, then write your answer in the comment section. The integral of 2 times 5 raised to x dx. You write your answer in the comment section. Two. So we have one answer here from Nikolai. Nikolai ba yun? Wait. Okay, so we have one answer from Nikolai. That is 2 times the quantity 5 raised to x all over ln 5, then plus c. How about yung iba? Do you have the same answer? Okay, so did you get the same answer? Same ba tayo kay Nikolai? Mm-hmm. Okay, so let's check if it is really 2 times 5 raised to x all over ln 5. So we will now have this one. 2 here is a numerical coefficient, right? So therefore, I can factor this one out. So we have 2, then integral of 5 raised to x dx, right? Now, again, from theorem B, the integral of 5 raised to x is just, so we have 2 times 5 raised to x over ln 5, right? And we have plus c. And actually, we can have this as our final answer. So, madali lang talaga siya. And actually, madali lang tayong matatapos ngayon. Okay? So, that's it. Now, how about number 4? You try this one. 3 raised to x plus 2 dx. Sige daw, kindly try this and write your answer in the comment section. 6 ln x, is it 6 ln x? How about yung iba? No, number 4 pa tayo ha, hindi pa tayo number 5. Number 4 pa tayo. Sige. So number 4, you try this and write your answer in the comment section. Now, as you can see, we have 3 raised to x plus 2. So yung exponent niya, x plus 2. But our formula for integration is only for a raised to x. Take note of this. Only for a raised to x. So therefore, you will do something to 3 raised to x plus 2. Dapat 3 raised to x lang siya so that you can apply this theorem. Okay? So, dapat may gagawin pa kayo dyan. So, ano kaya yung pwede nating gawin? If you have an exponent na na-add, anong ibig sabihin yan sa laws of exponents? Pwede nyong pwede ba nating i-separate itong dalawa? Yes, pwede. I-multiply. Very good. According to the laws of exponents, if we have 3 raised to x plus 2, I can actually write that one as 3 raised to x times 3 raised to 2. Right? They have the same base, so therefore we will add the exponents. Tama? So from that, we have this. And 3 squared, we know that that is 9. Right? So therefore, this will now be equal to the integral of 9 times 3 raised to x dx. And from that, pwede nating ilabas si 9. Then the integral of 3x dx. And this is now equal to 9 3 raised to x over ln 3. Right? And this is now our final answer plus c lang after. Okay? So you can have this as your final answer. I hope that is clear. Do you have any questions? If there is none, kindly press 4. Ayan. So madali lang naman siya, di ba? How about number 5? Number 5, may answer na si Giancarlo kanina. Di ba? Sige lang. Try natin siya. We have 6 over x dx. Okay? Ano nga yung answer kanina? What is now our answer for this one? Madali lang to. We have 6 ln x plus c. Okay, very good. Actually, 6 here can be factored out, right? So we will have 6 times the integral of 1 over x dx. Now, 1 over x dx, we know that the integral of that one is equal to ln absolute value of x. So we will now have 6 ln of absolute value of x. Always write the absolute value of x. Then we have plus c. And this is now our final answer. That is for number 5. Okay? And for number 6, yeah, number 6, last. Okay naman siguro yung 5, no? Do you have any questions? Okay lang ba siya? Okay. Now, number 6 for the last one, what will be the integral? The same lang to. So, number 5. So, hindi ko na nilagay yung mga complicated examples. As long as you know the basics, then you can answer or compute the integrals of exponential and logarithmic functions, dx. So, we have 1/2 ln x. So, very good. So, I can put 1/2 outside the integral sign. So we have x to the -1 dx. X to the -1 is just 1 over x. So therefore, the integral will be 1/2 ln of absolute value of x. Then we have plus c. This is now our final answer. Any questions so far? Clarifications for exponential and logarithmic functions? Are we all good? Okay, if there is no more questions, clarifications, kindly press 6 naman dyan. Ayan. Very good. Okay, so that's it for exponential and logarithmic function. Now, let's proceed to the next one. So, we have the antiderivatives of trigonometric functions. So, medyo marami siya dito kasi we have 6 trigonometric functions, right? So, therefore, we will also have 6 theorems for what do you call this? The antiderivatives of trigonometric functions. Okay? So let us recall the following. Okay, you already know this one. The derivative of sine x is equal to cosine x, right? The derivative of cosine x with respect to x is equal to negative sine x. The derivative of tangent x with respect to x is equal to secant squared x. The derivative of cotangent x with respect to x is equal to negative cosecant squared x. The derivative of secant x is equal to secant x tangent x. And the derivative of cosecant x with respect to x is equal to negative cosecant squared x. Okay, so you recall the following, and from that, we will have the following theorems for the antiderivatives of trigonometric functions. So please take note of this one. First, the integral of sine x with respect to x is equal to negative cosine x plus c, because the derivative of cosine x is equal to negative sine x. So therefore, the integral of sine x is equal to negative cosine x. So nagkabaliktad lang yung signs nila. Right? Tama ba? Are we all good? So medyo dito tricky siya na part kasi na mimix natin yung differentiation rules and integration rules. Okay? Take note that derivative of sine is equal to positive cosine, but the integral of sine is equal to negative cosine because the derivative of cosine is negative sine. Nakuha niyo ba yun? Okay, so please take note ha, wag niyong imimix yung differentiation rules and integration rules. Next, for cosine, take note the derivative of sine is cosine. Therefore, the integral of cosine is sine. Okay, so the integral of cosine x with respect to x is equal to sine x plus c. Okay? Next, the integral of secant squared x dx. Take note, the derivative of tangent is equal to secant squared x. So therefore, the integral of secant squared x with respect to x is equal to tangent x plus c. Okay? Next, the integral of cosecant squared x dx is equal to negative cotangent x plus c because the derivative of cotangent is equal to negative cosecant squared x. Right? For letter E, the integral of secant x tangent x with respect to x is equal to secant x plus c. And for the last one, the integral of cosecant x cotangent x dx is equal to negative cosecant x plus c. So please take note of the following. formulas for the antiderivatives of trigonometric functions. Okay? So please take note, you take a screenshot because later we will apply these formulas for the computation of the antiderivatives of some trigonometric functions. Okay? So are we all good? Sige, let's try to apply these theorems for these functions. Ayan, lima lang naman sila. Ayan. Okay? So first, we have cosine, integral of cosine x minus sine x. We have dx. Ayan. So let's try. So first, we can distribute the integral sign, right? So we have the integral of cosine x dx minus the integral of sine x dx. Again, what is the integral of cosine x? What is the integral of cosine x? Is it positive or negative? It's positive sine x, right? So we have sine x here. Then we have minus. What is the integral of sine x? What is the integral of sine x? Negative cosine x. So we have minus cosine x. Then we have plus c. And simplifying, we will now have sine x plus cosine x plus c. And we can have this as our final answer. Okay? Now let's have number 2. The integral of cotangent squared x dx. Now question, do we have a formula for the integral of cotangent squared x? Do we have a formula for cotangent squared x? No ata, sir. Yeah, wala. How about for integral of cotangent only? Do we have a formula? Yes. What is the integral of cotangent? Meron ba? Integral of cotangent x? Meron ba tayong formula? You review the theorems. Do we have a formula? No, sir, wala. So therefore, hindi pa natin magagamit yung theorems na na-introduce natin kanina. Okay? So we cannot use those theorems yet, but take note, cotangent x can be expressed into something else. Okay, using the ang tawag doon, identities of trigonometric identities. Do you know any identities for cotangent squared x? Okay, so dito naman papasok ulit yung mga identities. So as what I've said sa mga previous lessons, inuulit ko to, do not forget the identities kasi magagamit talaga siya parate. Okay? It will make your solving easier if you know the tawag dito, the trigonometric identities. So what identity are we gonna use? Can you still remember? Okay, so we have one here, cosecant squared x minus 1. Okay, that is from one of the Pythagorean identity, I guess. So we have from the Pythagorean identity, 1 plus cotangent squared x. If I'm not mistaken, this is equal to cosecant squared x. Right? Am I right? Di, di ba tinuro ko yung hexagon? Hexagon yung ini-imagine ko kasi. So 1 ang nandito, si cotangent nandito, so equal siya kang cosecant. Cosecant. Right? So therefore, we have that 1. So from that, we will now have cotangent squared x equal to cosecant squared x minus 1. Right? So from that, I can rewrite this one as the integral of cosecant squared x minus 1 dx. Right? So from that, we can distribute the integral sign. So you will have cosecant squared x dx minus the integral of 1 dx or just dx. Okay lang ba? Dx na lang. Wag nang lagyan ng 1. Okay, so the integral of dx. Now, question. Do we have a formula for the integral of cosecant squared x? Yes or no? Do we have a formula? Yes. And what is that? What is the integral of cosecant squared x? Negative cotangent x. So therefore, we can have this one as negative cotangent x minus what is the integral of dx? What is the integral of 1 dx? Ayun, nakalimutan na yung polynomial functions. Ano nga yung integral ng dx? We have x. Okay, do not forget ha. Minus x dito. Then we have plus c. And this is now our final answer. Okay, so do not forget the theorems na na-discuss natin. Okay, eraser. Erase, erase, erase. Who has questions, clarifications for number 2? Do you have questions, clarifications, guys? For number 2? If there is none, kindly press 2 rin para makaproceed tayo sa number 3. Ayan, very good. Now, for number 3, we have the integral of tangent squared x dx. Question again, the same question kanina sa number 2. Do we have formula for the integral of tangent squared x? No po, sir. Yes, wala tayong formula. But however, the same with cotangent squared x, you can express tangent squared x into something else, right? And what is that? How are you going to express tangent squared x? What is the equivalent form of tangent squared x? If cotangent squared x is equal to cosecant squared x minus 1, what is the equivalent form of tangent squared x? So we have here answers, secant squared x minus 1. Very good. That is again according to the Pythagorean identity, one of the Pythagorean identities. So we have equal to integral of secant squared x minus 1 dx. And again, we can distribute the integral sign. So we have the integral of secant squared x dx minus the integral of 1 dx or just dx. Okay? And what is the integral of secant squared x? Medyo mainit. What is the integral of secant squared x? Okay, we have tangent x. So therefore, we have tangent x minus integral of dx. We have x minus x, then we have plus c. Okay, so that's it. Okay ba? Now, how about number 4? Yeah, number 4. We have the integral of... before that, do you have questions for number 3? If there is none, press 3 tayo. Ayan. For number 4, we have sine x over cosine squared x dx. How are we going to integrate this one? You try this one in your seats or in your paper there. Try this one. What will be our integral? Sine over cosine squared x. Andyan sec. Okay. So medyo madali lang pala to. Okay, so we have one answer already. We have secant x plus c. Who else has an answer? Sige, let me ask Giancarlo. Giancarlo, can you please unmute your mic?
Yes, sir.
Okay. How did you get secant x plus c? What did you
Uh,
do?
ang second ay ang sine x over cosine squared x, sir. Pwede mo na to saying sine x over cosine x times 1 over cosine x, sir. So, same
Then,
na sila, sir. And sa properties dayon sa trigonometric one, sir, ang sine x over cosine x is tangent x times 1 over cosine x is secant x. So, na din sa kwan, sir, na din sa iyahang na din sa antiderivative, sir, nga ang secant x times tan x is secant x plus c.
okay, very good. Thank you. So, nakuha nyo ba yun? Okay, so if you really know the identities na pwede nating magamit, then walang problema talaga sa ating solution. So, from here, as what Giancarlo said, we can rewrite this one as sine x over cosine x times 1 over cosine x, right? They are just the same, dx. Now, from that, or pwede nyong baliktarin, una si 1 over cosine times sine over cosine. It's up to you. Now, take note, sine over cosine is just equal to tangent, right? So, we will now have the integral of tangent x, and 1 over cosine is secant x. So, we have secant x dx, right? And from our formula, the integral of secant tangent, so I can rewrite this one as secant x. Pwede nating i-rearrange tangent x kasi multiplication lang naman yan, dx, right? The integral of secant x tangent x is equal to secant x, then we have plus c. I hope that is clear. Clear ba siya? Do you have any questions? If there is none, kindly press 4. Pa-4 naman dyan. If you have questions, do not hesitate to ask. Ha? Baka yung iba dyan nagre-review kasi may summative sa stat mamaya. Ha? Alam kong may summative kayo mamaya. Oh, sige lang, madali lang to. Last number 5, then we will end the discussion para may time kayong mag-review. Di ba? Instead of patabang Mr. sa summative. No. Hindi. Kaya nyo yan. Okay? Kaya nyo yan. Now, let's have number 5. Number 5. We have the integral of 1 over secant x cotangent x dx. Okay, you try this one in your paper there, then you give me the answer. Ano ba answer nito? Nakalimutan. Yeah, 1. Mm, mm, 1 over so cosine times cosine times. Ah, yeah. So what is the answer? Nag-message si PLDT. May raffle daw sila pa raffle. Sige daw, what is your answer for this one? 1 over cos 1 over sine. Medyo mahirap ba siya? Number 5. Ganito siya, express secant as the reciprocal of cosecant. Cosecant, cosine, right? Then cotangent, express nyo siya in terms of sine and cosine. So what do you think is the form? Sige daw, let's do it together na lang siguro. We have this integral of, but you still try ha, 1 over, secant is just 1 over cosine, right? And cotangent is what? What is cotangent in terms of cosine and sine? What is cotangent? Hello? Cosine over sine. So we have cosine x over sine x. Masosolve ba to? Ay, yeah. Okay. So cosine, 1 over cosine x, then we have cosine x over sine x. You can actually, what do you call this? Cancel out cosine, right? So what's left is, we will now have the integral of 1 over 1 over sine x dx. Now, 1 over sine x, okay, dividing fractions, you can actually have it as 1 times the reciprocal of 1 over sine, right? So 1 times the reciprocal of 1 over sine. What is the reciprocal of 1 over sine? That is just sine x, right? So sine x na lang yung natira. So therefore, this is just the integral of sine x dx. What is the integral of sine x dx? Negative cosine x. And that is now our final answer. Ayun. So madali lang naman siya, di ba? Do you have questions, clarifications? Gets ba to? Si number 5? Tama naman siguro yung ginawa ko, no? Any questions, clarifications, guys? If there is none, kindly press 5. Ayon. And if there's no more question, I think I am going to end my discussion here. Kasi next meeting, we will discuss some techniques, okay, in finding the integral of a certain function, the indefinite integral. And from there, we will learn the substitution rule. Okay? So, ibang technique yon. Kasi may ibang functions na hindi siya masosolve using the basic integration rules. Okay? So, we need the other techniques. Okay, so I think that's it for today, guys. Okay? Is there any questions, clarifications so far? Take a screenshot muna for this one. I think meron na kayong kopya, no? Sige, discard ko na siya, ha? Ayan. So I think that's it for today. If there's no more questions, clarification, are you all good? If wala na, thumbs up naman dyan. Pa-thumbs up naman tayo. Okay, before we are going to end. Ayun. So that's it for today, guys. No, madali. So early lang siya. So stop na natin yung recording. Dito magi-end yung recording. Ayan. O, 'di ba? Thumbs up emoji. Okay. So, yeah. That's it. Stop na ba siya?